and we will get started. So the first thing that we're going to be taking a look at today is sketches. So sketches are obviously one of the most common areas that we all work in, and this is going to be a big focus to the enhancements to SolidWorks 2014, is that there is a big focus on small things that you use a lot rather than big flashy things that you may use rarely. So I'm going to start just by editing this sketch, and I'm going to dimension this circle that we've got here. Nice simple stuff. You can see right now the size of this circle is just short of 100 mil. I'm going to change this dimension to 35. And what we would expect to see as existing SolidWorks users would expect to see that circle to shrink down. And this is a common issue that people have run into with SolidWorks, with a lot of parametric CAD, is when you rough the sketch out, if your sketch is very much larger or much smaller than what you've dimensioned, you'll see the things shrink or grow, it can overlap and things like that. But in 2014, if I hit the tick, you'll see nothing changes, but the dimension is correct. So what's actually happened in the background there is that it has changed the size of that circle, but it's also scaled the rest of the sketch down with it, and then changed the viewport's zoom level so that nothing appears to change. So this is one of these things I was talking about where there's a big focus, because for new users, they wouldn't even know how it used to work. But for grizzled old SolidWorks users like us, we understand what a boon this is to be able to rough your sketch out without having to care how large the actual sketch is, and then to have the whole thing scale for us when we apply that first dimension. I'm just going to add a few more dimensions to my sketch here. And what I'd like to do now is to make these two circles equal. I could use Control Select to select these two circles, but I want to look at another method that we're introducing in 2014 called the lasso selection. So we've got box selection, which we all understand. If we go from left to right, it selects everything completely inside the box. If we go from right to left, it selects everything inside the box or crossing the box. If we right-click, though, and select lasso selection, we get something that those of you who've used paint tools and things like that, like Photoshop and other programs, will be fairly familiar with the lasso tool. So what that allows me to do is to draw an area out, and it will select everything contained in that area. But again, it still behaves the same way as our box selection. If I go the other way around, so anti-clockwise, it turns green, and anything touching or crossing or completely inside the lassoed area is selected. So this is a much faster way for us to select these two circles. I can just do a lasso that touches the two circles there, and I can make them equal. So you can imagine if you've got a lot of items that you need to pick out that may be difficult to select from to select using a traditional box selection, the lasso selection is definitely a great enhancement. So I'm just going to dimension these circles now. And finally, one more improvement to sketching is we have a new dimension type. So if I start the dimension tool, right-click, more dimensions, we have path length. So what this allows us to do is to select a large group of items. So I'm just going to use select chain to select all the elements around here. You can see they've been added into the box. And what this will do is dimension them all, keeping them relatively the same size to one another that they were when you added that path length dimension. So I can now drive this to be 265, and it drives that path length to be 265. So another great improvement to sketching in 2014. And again, it's not a huge improvement, but it's if it's something that you need, it's going to be a boon for you when using sketches. All right, we're going to move on to the next demonstration now, and we're going to stay in sketches. What we're going to take a look at, though, is the Sketch Picture Scale tool. So Sketch Picture is a tool that we've had available to us for a very long time now. But one of the issues that we've had has been around the issue of scaling that picture correctly. So I'm just going to insert a sketch picture. For those of you who aren't aware, we have the ability to search for our commands now as of 2013. So up in this command search box up here, I can start to type sketch picture, and here it is. I can click on that, and it's going to run that command for me. I'll just navigate to my picture, and it inserts it, but it is way too big. So what I'd like to do is set, as you can see from the picture, the parting line basically through the middle of the head right here, we want to be 6.5 inches and match up with this sketch line that we've got down here. So what we have now, we could just drive the overall width and height of the picture the same way we always have, but we have a new tool to do this much faster. So I can grab the end of this scale tool, drag it up to one end, grab the other end, and I can stretch it out and make it smaller and get to the end there, and then drive the length of that scaling tool. What this now allows me to do, I can grab it by the end and drag it near to the end there, and I can even rotate the picture with the other end as well. So another enhancement to sketches that improves that workflow that you've got when working with sketch pictures. All right, sketch splines and conics. So this is one of the big, I guess, marquee improvements to SolidWorks 2014 has been around conics. So we've got a fairly complex part here with some fairly complex curves, and we're going to have a look at how we can use conics to improve the appearance of these designs. So I'm going to search for my strength rib sketch. Just so for those of you who aren't aware of the filter bar up the top here, this allows you to start to type the name of a feature in your feature manager tree, and it will filter out everything that doesn't match what you type up here. So this isn't new for 2014. This has been around for a while, but it's something that you may not be aware of. So I'm going to use that now to edit my strength rib path here. And currently I've got these two arcs, these two circular arcs at the end. I'm going to replace these with conics. So I'm going to delete these two here, and we're going to use this new sketch tool. The sketch tool is found underneath the ellipse tool, so both up here on your sketch toolbar and obviously also on your shortcut bar if you press S. So I want to use the ellipse tool and come down to conic. All right, so there's a couple of options they've got. We can have the conic be set to be for construction. We also have another option here called auto tangency. What this is going to do is automatically set the beginning and end of my conic to be tangent to whatever entity I start and end it with. So if I click on the end here and the end here, it's automatically going to make the ends of that conic tangent. I'll use my dimension tool to set the row value. The row value basically sets the sharpness of the conic at the midpoint. So this is a continuously, a curvature continuous shape. So it has zero curvature at these points here where it joins the lines. It will be curvature continuous through, and we use this dimension here, which can change from basically 0.95 all the way down to 0.05. And we can see that it basically moves it almost from a chamfer up to a point, depending on what value you set that row value to. So I'm going to set the value here to 0.7. And I'll do another conic on the other end. So we start underneath our ellipse tool, conic, make sure we've got auto tangency, start, end, and then click to place it down, and then I'll use my dimension tool here to set the row value. And then finally I'm just going to use fully defined sketch to add the final dimensions that I need here. Alright, my sketch is now fully defined, and I'll close that. I'm now going to use the same tool, the same Conic tool, to modify this sketch that we've got for the strengthening rib itself. So I want to get rid of this flat face on the bottom, and rather than replacing it just with a circular fillet through here, I want it to be curvature continuous at the join and around. So I'm going to delete the line and also its dimension, and I'm going to replace it with a conic. We'll dimension it. This time I'll make it a bit flatter than I had it before. And you'll also notice that the focus point of the conic actually has a sketch point on it. So this allows me, for example, to drag the tangency point there onto the origin. So now both the profile and the path that forms this strengthening rib have been formed using those conics. All right, this next improvement is another one that has been asked for quite some time, and it's with regards to splines. So what I've got here is an underdefined spline, still blue. It does have lots of dimensions setting the shape. What I would like to define is the length, the overall length, so the undeveloped, if I was to stretch it out, what would be the undeveloped length of this spline? We can now use, as of 2014, the dimension tool to just click on the spline to drive the length of it. So I can set the overall length of that spline to 850. All right. Also, staying with splines, we now have a brand new type of spline called the style spline. As a general rule, it's a simpler form or simpler tool to be able to create splines to get much nicer shapes than you would get with the typical spline tool. So I'm going to use an existing sketch that I've got here to show you. So this is our existing spline. It looks okay, but if I was to bring up the curvature combs for this spline, we can see that it has lots of inflection points where the curvature is changing from being concave to convex and back again. And in the end, if we were to machine something based on this, you would generally end up with more tool wear, and the shape itself is not going to be as aesthetically pleasing as if we had fewer changes in curvature. So I'm just going to hide the curvature combs for this, and we're going to create a brand new spline. So underneath the spline tool now, we have an option called style spline. All right. So the style spline allows us to build a frame. So I'm going to click at this endpoint here. I'm going to bring it out. And you can see I'm not actually drawing the spline, but I'm drawing a frame that is defining the spline itself. And I'll end down here and then escape to turn it off. And we can use this frame to change the shape of the spline. So for example, if I want this to be tangent through here, I can just make these two lines here perpendicular to one another. Or if you had a line running out here, you can make it collinear. I'll do the same thing on the other side. And we can dimension this frame as well. We'll locate that below the origin. And you can see it's much easier to control the shape using this frame than it is using the spline handles that we would traditionally have to work with. I'm pretty happy with that. So let's now have a look at the curvature comb for my style spline. So you can see here the shape for this style spline has a much smoother flowing curvature through the shape here. But I've got a problem now in that this spline here is the old one and this is the new one. But it's not going to be as simple. Replacing it is not going to be as simple as just deleting the old one, because this actual sketch entity here is being used in another feature for the path of a sweep, for example, or maybe as part of a loft or things like that. What I actually want to do is find everywhere where this sketch entity is being used and replace it with this sketch entity here. So we have an option to be able to replace the old entity with the new entity. So if I right click on here, we have replace entity. I can find it. It's probably right in front of me and I cannot find it. That's because it's up the top here. So replace entity. So it's actually in the left click menu. So if you left click on it, we've got replace entity. So click on replace entity. All it asks for is the old entity, the new entity, which I want to be my new spline, and it wants to know what to do with the old entity. So we can either make it construction or delete it completely. So for this example, let's make it construction. And we can see now it's replaced the old entity with the new one, and it's made the old one for construction. I'll just turn off the curvature combs now. And we can close that. And we've replaced the old entity in the sweep as the selected sweep path with this one here. So there's another focus that we've got in 2014 with the improvements in terms of getting ahead of the problems. Obviously, if we thought about how this would occur currently with 2013 and older, is that we would have just deleted the old entity, closed the sketch, the sweep would have failed, we would have had to go into the sweep and select the new entity that we wanted to be the sweep path. But that's an extra bunch of steps that you need to go through, and if that sketch entity was used in multiple features, that extra time obviously multiplies out. Alright guys, before we go on with the next demonstration, I'd like to run another quick poll, and this one is about the what your intentions are in terms of upgrading to 2014. So whether you've already upgraded, whether you are planning to upgrade but you're waiting for later service packs, whether you don't plan to upgrade at all, or if you're not sure. So I'm just going to pop that one up there. And we'll just get an idea where people are at in terms of upgrading to 2014, so you can see how your company compares to everybody else. All right, so a few more people just putting their votes in. All right. I'll pop that up there. So you can see there's a lot of you that have already upgraded. Another 30% are going to wait a little bit later. And yeah, about a quarter of you aren't sure at this stage. All right, guys, let's continue on. We've got a few more presentations to go through. The next one that we're going to take a look at is the sheet metal demonstration. So I'm going to bring up my sheet metal part. All right, so we've got a sheet metal part here, and the first thing that we're going to take a look at is this swept flange feature that I've got created here. Was introduced, I think, last year in 2013, but there has been some very specific issues that some people have come across when creating swept flanges. So if I was to flatten this part out, you can see it's not the flat pattern that we're expecting to see, sort of running around the curve instead of with it. So we have the ability now with the swept flange, if I edit the feature, to select this cylindrical conical bodies option and to pick a sketch entity or an edge to define the face that is going to be unfolded first. So now if I flatten that out, we get the flat pattern that we would expect to see. All right. So the next feature that we're going to take a look at is the gusset. Excuse me. So we've always been able to add features using the forming tool, but SolidWorks has never been terribly happy about applying forming tools across bend regions. So we now have a specific tool called the sheet metal gusset that allows you to very easily add a gusset in a similar way to how you can add gussets to weldments. So we define the position of our gusset. We can specify the location by changing the offset. We can specify it either by indent depth, how deep we want to push in, or we can actually specify the profile dimensions. So in this case here, I've set it to say 15 by 25. We can also play around with whether we want it to have a square base to it, or whether we want to have a rounded base to it. If we set it to have a square base, we can set the filleting of the edges here. I'm going to select rounded. My indent width, let's say we've set that to say 8, bring it out there. The thickness, I want to set that to be equal to the thickness of the sheet metal part. So just by deleting out that, we can actually link it to this pre-existing variable that we've got here. So it's going to be whatever you set the thickness of the sheet metal part, that's what we're going to set the thickness of our indent to. The draft, so obviously if we're forming this, we don't necessarily want these sides, these triangular sides here, to be parallel. We want them to have a bit of draft to them, so I'll pop that in there. And we've also got the fillet for the inside and outside. This is looking pretty good, so I'm going to hit the tick. And there's my formed fillet, so my formed gusset. So nice, fast way of applying that feature. Now, another option that we've got here, when I run this command, like most other commands now in SolidWorks, SolidWorks is going to automatically repeat all of the options that we had set previously. So I don't need to go back through and double check that all of these settings are the same as what I had over here. These settings will be exactly the same as what I had with the previous one. So it's as simple as just picking the two faces and then hitting the tick. All right, another improvement to SolidWorks is the, what am I trying to say? Sorry, is the corner relief enhancement. So corner relief has always been available with sheet metal parts, but the issue has been it doesn't display in the folded form. It only ever displayed the corner treatment in the flat pattern. So what we have introduced in 2014 under the corners option here is corner relief. So this allows us to collect all the corners that are applicable to apply some corner treatment to. And then we can specify for each type for each corner what type we want. So I've got them all selected. I can make them all rectangular, or I could set them to be different. So maybe I want this one to be circular, I want this one to be tear, and I want this one to be oblong. Hit OK, and we can see the corner relief applies not just in the flat pattern, but also in the folded state. All right, the last example that we're going to show for sheet metal is to do with lofted bends and showing the transition from one form to the other. So I'm going to create my lofted bend, and we now have the ability to control the faceting options of each fold region individually. So we can control it by chord tolerance, so we can specify what is the maximum deviation from the ideal curved shape, which is this one here, and the true faceted or flat shape. We can just specify a number of bends. So how many chatter bends do you want through each selected bend region? we can specify the segment length, so how long is each bend, or the segment angle, so what angle do you want between each of these bends here. And we can even control these in each bend individually. So if I set the global one to be chord tolerance, I can actually select the little dot here and change this one and say, no, I want this one to be set by the number of bends and I want 4. Hit the tick, you can see the true shape, and then when I flatten it out, we can see the fold lines for each fold through there. So a big improvement for lofted shapes or lofted sheet metal. Alright guys, next one that we're going to take a look at is to do with parts and weldments. So the first thing that I want to show you is something that it might be a little difficult to show through the webinar. I'm not sure how clearly this is, but most of you would be aware of it, and that is this bleed through of edges when you've got very thin parts viewed at a distance like I am doing at the moment. So what you end up with are these, you can see almost sort of like x-rays, you can see through the thin part and you can see the edges of the components through it. As of 2014, when you stop rotating, so when I let go of my middle mouse button here, it will repaint and eliminate those. No matter how far away you are, it will repaint to eliminate those bleed through of those edges. So you can see the edges there, and then when I let go of the middle mouse button, it repaints to get rid of them. All right, but the big headline improvement for weldments in 2014 is definitely the introduction of configurable weldment profiles. So if I go up to weldments, structural member, and I select this weldment profile standard, you can see that it's listing some of these types as configured. The reason for that is the location that I've set for my weldment profiles here is this folder here, is what's new weldment profiles, and you can see there's actually only 3 parts in here. There's only 3 parts through here. Each of these has configurations in them. So the 3 parts that you see here equate to the 3 types that we've got. So if I go to, say, square tube, and the sizing are now controlled by configuration. So you can use things like design tables to be able to control the sizing of your the sizing of your weldment profiles. So this has 2 big, I guess, effects on weldments. One, of course, is file management becomes much, much easier because rather than having to have a library feature part for every single size that you've got here, you only need 1 for each type, and then you can set the sizes in your as configurations. Secondly, we would all be familiar with having to replace one entity with another and then having the whole thing flip to the opposite side when we change the size. That's typically because of how the sketch has been set up in the various library feature parts that we use for our weldments. The improvement that we get with the fact that these are just configurations that change the sizes of the sketch entities is that you can change your sizing without it ever flipping around because the actual entities themselves are not changing, they're just changing by size. One question that I did have during the live presentations was what this means for your existing weldment profile libraries. Happily, this can coexist with your old profiles. So you can see this does not have configured next to it because this is one of the old weldment profile types. So your configured types can live side by side with your old weldment profile types. You don't need to go through and recreate all of your old or your existing ones in order to get the benefits. Or another one of my favorite improvements to 2013 is if I edit this whole wizard hole here, we can see we have a brand new row of icons down the bottom under the whole specification, and that is because we now support the slots. So we support counterbore slots, countersunk slots, and straight slots. By the way, guys, I do see that the people have got questions that are coming up. What I'm going to do is leave that. The questions will stay there and I will answer them. I'm just going to wait to the end. So feel free to use that questions area to put your questions up. I will just be waiting till the end of the presentations to answer those questions. So I've got the counterbore slot tool here. So I'm going to switch my counterbore hole to a counterbore slot. I can switch to the positions tab, and basically all that has been added is this construction line that I've got through here, which is defining the length and the orientation of the slot. So if I change the orientation of the line, it changes the orientation of the slot. And I can just use some sketch relations here, make them parallel, and we've now made that fully defined. I'll close that. And because we've patterned that hole, it now appears everywhere else. So these, as we saw there, are fully interchangeable with your existing whole wizard holes. All right, another one of these improvements that's a small improvement to a feature that some of you will use quite a lot. I've got a sketch sitting in the middle of this block here that I want to use as a through-all cut in both directions. Traditionally, what we would need to do here is start the extruded cut, select through all for the first direction, select the checkbox for the second direction, and then select through all for that. As of 2014, we have a new option under extruded, for both extrude and extruded cut, of through all both. All that does is it sets it to be through all, clicks the checkbox for direction 2, and sets it to be through all as well. So it's a little thing, but for those of you who need to use, who do need to use through all in both directions, it's going to save you quite a bit of time. All right. Now, another improvement that I have to admit I wasn't aware of that came through in 2013, it's now been improved in 2014, and that is the ability to be able to delete features without automatically deleting all of the child features of that feature. So this mounting plate center plane that I've got here, if I delete that, we can see that all of its dependent items here, so the sketch, the boss, so we've got a boss extrude out here, the cut extrude 3 that I just did, as well as the mirror feature to the other side, all of these features would normally, prior to 2013, would be deleted. In 2013, we introduced the ability to be able to delete or not delete those child features. However, it was a bit, it was all or nothing. So you either had to delete all the child features or none of the child features. In 2014, if we select Delete Child Features and click on Advanced, we can now choose which children to delete. In this example, though, I'm not going to delete the child features. So all that ends up with is that some of our features are now left dangling, but we're all experienced SolidWorks users here, so we can very easily create a new plane to be able to link these sketches to. So I'm going to roll back to before the feature. Obviously the plane needs to exist before we do that. And I'm going to create a plane at the mid-plane, mid-surface of these two faces here. So reference geometry plane, it defaults to mid-plane. The improvement that we get with 2014 is this flip normal option. So flip normal allows me to change which is the front and which is the back of the plane. So which is the green side, which is the red, or blue and dark blue, just depending on your color scheme. So for those of you who've had to move sketches from one plane to another and then found that their extruded cuts or their extrudes end up flipping and going in the wrong direction, this is the tool you need to orient the plane in the same direction as the outgoing plane. So again, we're coming back to this idea of getting ahead of the problems. Rather than just causing the problems and then fixing them as they come, we get ahead of the problems so that they never occur in the first place. So create the plane, and I can go into my, edit my sketch plane, pick up the plane, and same with this one. And we're done. So a much more efficient method rather than deleting all the features and having to reattach or recreate them or reattach them. All right. We also have some improvements with regards to reference points. So if I click on reference geometry point, we've got a few new ways of creating these reference points in parts. So the first is at the intersection of an axis and a plane. So if I pick this axis running through the middle here and this right plane that I've got up here, we can see our reference point being created here. If I delete the plane, I can also do the same thing to create the reference point at the surface, the intersection of the axis and the surface. If they intersect, we also have the ability to create a reference point at the intersection of two axes. So if I view axes, I've got an axis at the center of my table here, and I can create an intersection of the a reference point at the intersection of the two axes that you see here. We also have the ability to create them on point with a sketch point and on point at the end of a sketch segment, like a line or an arc or a spline. All right, volume properties. We now have the ability to set volume properties using traditional unit types. So our options previously have been things like cubic millimeters and cubic inches and things like that. We now have the ability, if I go into my cut list, of adding volumes in liters. So we can set our document property for our units. So for per unit volume, we have things like liters and pints, gallons, and fluid ounces. Finally, when I save out this body here to a new part document, so if I insert this into a brand new part, we now have the ability, previously we've had the ability to extract the cut list items out of the Weldment cut list, but it's only ever been able to drive them into another cut list in the destination part. We now have the ability to drive these properties from the parent Weldment into the file properties of the destination part. So hit the tick. It brings up a dialog box saying, hey, the destination template is not using the same units of measure, for example, liters, as the one we're deriving from. Do I want to change them? Yep. I won't save it, but now if I bring up the file properties, so not the Weldment properties, but the file properties, we can see these are all linked back to the original part and display their properties here. So for those of you that like to work with Weldments but need to include the Weldment items as bills in bills of materials and have the properties evaluated correctly, this is going to be a great improvement. All right, we've got a couple more demonstrations to go through before we get to the Q&A session. All right. That conic that we had a look at in sketching has been carried through to the filleting tool. So we're going to have a look at how we can create more aesthetically pleasing and easier to machine shapes using the conic fillet tool. So this fillet that I've got here has been created just using a traditional circular profile fillet. So I'm going to delete that and add my own fillet onto this edge here. So I've got a constant size fillet here. The big change in 2014 under the fillet parameters is the ability to change the profile. So we've got circular and two conic options. Conic row, which allows us to set a row value, which is similar to the settings that we had when we created the conic in the sketch, or conic radius. So the conic radius sets the value at the halfway point of the fillet. So the radius is obviously curvature continuous at the start, but it will change to be this at the halfway point. So let's have a look at the effect of setting some of these things. So actually I'm going to take this one step further and we'll make it a variable fillet around here as well. So I'm going to set the value to be 10 mil with the conic radius to be 10 mil. Pick up the top here as well as the sides down here. All right, so I'm going to set all of them to have these default values, and now I'm going to play around with the values so you can see the effect of the changes of these two values, this radius and conic radius. So at the top here, I'm going to set the radius to be larger, and what you're going to see, the base lines here. So this line here and this line here are going to grow out further, as you saw there. But what I'm going to make smaller is the conic radius. So at the top here, it's going to get pointier. It's going to get sharper because I'm going to change this value. So you can see it starts larger and then gets smaller than the rest of the fillet. And just like everything else in a variable radius fillet, that's going to blend smoothly down to these points here. And finally, down in the lower points here, I'm going to set these to 10 and 5. All right, that's looking pretty good. I'm going to roll to the end now. And we're going to apply a few more fillets up the top here. So one of these is going to be a face fillet. And we're going to blend this face here into this fillet here. And you can see the preview that we've got. And just like in our constant radius fillets, we have the ability to switch from circular to one of our conic options. But we have another option when we use a face fillet, and that is chord width. So you can see we can specify the chord width along here, or we can specify the radius just like before. So I'm going to set that to radial, 5 mil. I'm going to use a conic radius of 1 mil. Hit the tick, and you can see the effect there. We start large, get tight, and then get larger again as we come out and blend into this face here. The last one that we're going to look at, just a constant fillet around this face here, all the way around these faces here. Constant size of 5 mil with a conic radius of 1 mil. And again, we get a similar shape to what we've got up here. So it starts curvature continuous and then gets tighter and then comes back out again and flattens back out. All right, guys, the last example that we've got for today is drawings. I'll try and get through as quickly as possible. I've got 12 minutes or so left. All right, so drawings. The first thing that we're going to take a look at is the introduction of a new annotation plane called the notes annotation plane. So if I open up, sorry, wrong component. I bring up my drawing. Got a part here, and you'll notice there's a table in here called the title block table. If I show that, you can see it zooms with the part but does not rotate, so it's stuck to the screen. Where this can be really handy is if you're in the very lucky situation of not needing to use 2D drawings to get your parts manufactured. So if all you need to supply to your supplier is the 3D model, a lot of you have had the issue where you've needed to create a drawing for the sole purpose of capturing this title block information. Now, using this title block annotation table, we have the ability to store that information in the part document itself. And these, just like drawings, these are linked to your custom properties. So they're linked to your properties that we see here in your part document. All right, coming back to the drawing, I would have to say my single favorite improvement to drawings has been a very simple improvement to the view palette. Some of you may have noticed it already, especially those of you who are obviously running 2014, and that is the fact that any views you add to the drawing are no longer taken away from the view palette. They stay in the view palette. They just get this little tick next to them to show that it already exists. So if I want to grab another bottom view, for example, I can grab that view, drag and drop it onto here without having to, even though there's already one existing, I don't need to go through the messy model view option just because we've already got a bottom view added. So one of my favorite improvements to drawings in 2014. Okay, and one of my favorite improvements overall, not just for drawings, in 2013 was the section view assist tool. Made it so much easier to be able to apply sections in your drawings, like snapping to holes and things like that. The problem came when you wanted to modify that. The only option you had was to edit the sketch. So you had to go back to the bad old days or delete it and recreate it. What we now have the ability to do in 2014 is the ability to edit the cutting line, and it allows you, if I pre-select it, we have the ability to use the section view assist to add in things like a section, and also a section improvement, so we can take a section right through the middle of this part. But I just realized what I want to do first, which I have skipped over, I'm making the next step very difficult, is I need to show you an improvement that allows us to swap views. So I want to replace the model that is in this drawing view. We've always had the ability to do that. The issue that we've had is that we've had to swap like for like. So we've had to swap parts with parts or assemblies with assemblies. What I would really like to do is, I realized I started to detail up this thinking it was the assembly, but it's actually the part. I want to replace the part with the assembly, but I don't want to lose any of my annotations or drawing views. I now have the ability to browse for and find an assembly, and here's where it gets really cool. Because the part that I'm replacing already exists in the assembly that I'm replacing it with, all of the annotations that you see here will not dangle. They stay attached because the part still exists in this assembly, so it knows where to attach these dimensions to. It also means I now have my lovely screw hole that I can run my section through. So now if I come back and edit my cutting line, I can use my jog option So I want to jog this through here, and now I want to run it right through the middle of this hole, hit the tick, and it's updated our section view, and you can see it's now passing right through the middle of that screw. So what I'd like to do is add some balloons to this stack here of the screw, the washer, and the nut. And to do that, rather than using auto balloon, I'm going to use the stacked balloon option. So under annotations, stacked balloon, I'll set the direction that I want them to stack, which is off to the left, and I'm going to pick the first component, which is the head of the screw, place that down, click on the washer, and then I've accidentally picked on the wrong component. I've picked on the lower base. So you can see there the part number is incorrect. When doing stacked balloons like this, if you'd made a mistake like that, you'd have to restart again. What we now have the ability to do is if I right-click on that balloon, I can reattach it. Right-click, reattach, and say, actually, I want to attach it to this captive nut here, and it reattaches it with the correct part number. So just another little improvement, but if you do a lot of the stacked balloons like that, I know how much of a hassle it is if, as you're trying to pick these very small components, occasionally you pick the wrong one and have to restart. While we're looking at this section view, I want you to take a look at this cover here. You can see we've sectioned through these two edges of the part. But if I open the part up and take a section through it, you'll see that this part is actually a surface model. So we're actually sectioning through these two surface bodies, which traditionally we haven't been able to do. So normally when you take a section through it, these edges would not display because we cannot section through surface bodies. As of 2014, we now have the ability to section, both display and cut surface bodies. As you can see through there. All right, dimensioning. So I want to take a dimension of the overall width, but the problem is I want the sharp. What we would traditionally have to do is insert the two virtual sharps and then apply the dimension between them. We now have a shortcut in 2014. So if I right-click and select Find Intersection and then select the second edge, it creates the virtual sharp. Come up to the other end here, we do the same thing, right-click, Find Intersection, pick the other edge, there's my virtual sharp, and we can place the dimension down. So we can now obviously reuse that virtual sharp just like any other virtual sharp. We've just now got a shortcut for the ability to be able to create those virtual sharps. All right, guys.